Good evening, everyone. So we are willing to wait up 2 or 3 minutes for other participants to join. Good evening, everyone. So we are delighted to welcome you to our online webinar on network and raster analysis using ArcGIS Pro. So we are excited to have you here today and look forward to an interactive and productive. So I am Chamodini Vijay, the moderator of today's webinar. So we are excited to have you join us today to learn more about this powerful GIS technology. We are GIS Solutions Private Limited, and we are a professional GIS service provider that has been providing GIS services to many clients and organizations over 10 years. So we specialize in implementing GIS technology for our clients and providing GIS training to ensure their success. First of all, I would like to invite our General Manager, Mr. Supun Sirivardhan, to explain about objectives and the benefits of this webinar.
Okay, thank you, Chamodi. I would like to welcome you all for this webinar, especially related to the ArcGIS Pro and the advanced functionalities of the Pro. So we had several webinars during last few months, and after that we had several trainings related to these particular subjects. So this the whole objective of this type of webinars is to encourage you for utilization of the software. So we have seen in Sri Lanka, the software has been purchased and software is available for many people, but sometimes there are products underutilized in your organization. So this is one of the areas which we need to address. So we have seen a lot of organizations using raster data, and there are plenty of analysis available with raster data. But most of you using ArcMap mainly for this type of analysis, and we would like to encourage you on ArcGIS Pro usage, and using that you can do various analysis, the same analysis, and also there are new capabilities in Pro. And also the network analysis. So it's another important area in GIS, which has been used for many decades. It was introduced sometime, maybe 10, 20 years ago, and there were a lot of functionalities. The simplest functionality is the shortest path analysis or the optimum path analysis. But nowadays, you have that capability in your smartphone. It has given you, because there are services given, and you can do it in your mobile devices as a client. So that capability is given to you. But there are a lot of hidden features inside this network analysis. So we want to highlight those features and encourage you to apply this technologies in your organizational requirement. So not only learning a product, applying the technology appropriate to your organization level. And also, I would like to give another message that today's webinar is not mainly conducted by me. I know several webinars conducted by me, but today this opportunity has been given for one of my colleagues, and he will go through these capabilities. So likewise, we have in future webinars, we have an idea for encouraging our users to join with us. So if you are capable in certain technology domains or applications, in future webinars, we would like to join certain customers or the certain users to present their capabilities. So in that, we would like to see a lot of practical applications, not just the PowerPoint slides. We would like to see a lot of practical applications or the software demonstrations, and we would like to develop your skills on those capabilities. So that is another message which I want to give you at the beginning. So with that, I would like to welcome you again behalf of GIS Solutions and also behalf of Environmental System Research Institute. So I would like to hand over again to Chamod.
Thank you so much, Mr. Supun Sirivatana. Next, I would like to invite our GIS analyst, Mr. Sivaruban, who is going to lead this webinar. Mr. Sivaruban is a highly experienced GIS analyst with a wealth of knowledge and expertise. So he will take you through the basics of network and raster analysis using ArcGIS Pro and show you how to apply these techniques to your field. So firstly, he will do the network analysis and then discuss about the raster analysis. And there's an important thing I should mention. You have to complete and submit the quiz that we will provide you at the end of the webinar. And it is necessary to have your e-certificate. So we hope you find the webinar useful and informative. Enjoy the learning lessons. Mr. Sivaruban.
Yeah, good evening all. This is me, Sivarasa Sivaruban. So, first of all, I would like to introduce myself. I'm working as a GIS analyst in GIS Solution Private Limited. So, you all have idea about our organization. So, it is a sole or the authorized dealer for ESRI products. And you all know ESRI, Environmental System Research Institution. So that is the biggest company in the world, still being provided the ArcGIS production in a successful way. So as a representative of GIS solution, I'm going to conduct this session. So hope all you have basic idea about ArcGIS Pro, right? So when we think about the ArcGIS Pro, in the history, there are several type of softwares. So from that softwares, it has been upgraded. Now we are using the ArcGIS Pro. So it has been the big upgraded. So first of all, our previous people historically, PC ArcInfo they used, and next ArcView, then ArcMap. So ArcMap, I think that is also have covered long years, and it has provided a lot of function to give a successful answer for the GIS users. So now we are in the era of ArcGIS Pro. So when we think about the ArcGIS Pro, it has lot of upgradation and convenient function tools it included. So normally you know how to access the ArcGIS Pro. So that is the basic thing. I think the people who already participated our online program, you may have known. I hope you all have understood about the ArcGIS Pro. So these are the basic structure of our ArcGIS Pro software. So when you go to this project, these are the ribbons, we call ribbons. So project ribbons, map ribbons, insert ribbons, analysis ribbons. So inside the ribbons, there are functions and buttons. So these are the basic idea about the structure of ArcGIS Pro software. So when we open the ArcGIS Pro, automatically in a default space, it will save. But anyhow, for like big project, if we keep that default location, sometime if our laptop or computer system will get crash, of course we cannot recover that document which we have done the works. So I suggest you to save the location which you are going to do the project. It's better in a hard disk and have a backup. With this suggestion, if you work, you don't want to worry about these crashes of this environment of any software or like system of the computer. So in this way, you can access this ArcGIS Pro. So now I can straight away go to that software and give that how it function, and I can explain the network and raster analysis, right? So before I go, I will give some brief and basic ideas about what is the network and what is going to give which kind of targeted expectation, right? So when we think about the network analysis, it actually gives us that there is a complex of the road networks or railroad networks or pathways networks. It's a complex one. So from that complex, we should get the simplest answer. So it's because of that these network analysis actually give us the convenient way to get the successful answer what we expected. So normally when you look at this picture, it is so complex. So from the complex, we want the simplest answer. So for that, we use the network analysis. So this is Sri Lanka data set. So from the data set, you can see how the network, it looks. Now, just to have an idea how it looks. All right. From that, now, of course, we come to like symbol, like we can have symbol idea. Now, it means now it has separated like a clusters. All right. So before we have so complex, now little we come to that simple cluster of structure. So now in this one, of course, you can clearly have an idea about, yes, something that it has a different structures and clusters. All right. So after we separated and normalized, we can have idea like in this cluster, what are the things inside that? Likewise, in this cluster, what are the things inside? So ultimately, through the network analysis, what we are expecting is we have to have an answer that should be simplest from the complex. It's so complex. If we go for manually, we have to spend long hours and long, like how do we call it? If we do it manually, this one of course takes more long time. So with the convenience of timing, with the convenience of our activity, we want to take it easy from the complex. So that is the ultimate and simplest idea you should take from this presentation, right? So now I straight away go to the software and do the function, and I will explain how this system works, mean the network, how it's work, right? Yeah, now you all are seeing this project window, all right? First, what you have to do is you have to connect the folder which you are going to do a project. So that is our first goal or target. So for the folder connection, you can see the catalog pane in the right side, all right? In the right side of your project window, you can see the catalog pane. In the left side project of this window, you can see the contents. And in the top side, it's a functions and ribbons and the buttons, all right? So in the catalog pane, on top of this folder, you can see maps, toolbox, maps, toolbox, databases, styles, and folder, right? So in there, this is the one. So in there, you can access the folder. So on top of this folder file, you can right click, and when you right click it, there's a pop-up window. It will show like this, add folder connection. So when you click the add folder connection, you can browse your location where you want to work, all right? So in here, my folder, I keep it in a desktop. It's because of today's webinar. But normally, I keep this folder and save my documents, working things in a hard disk. Hard disk means I mean that you don't keep any working folders or files under C drive, because C drive is functioning all the systems. So one system out, you can't get the recover. So it's because of that I suggested already to keep your working folder in a hard disk. All right. So for the webinar purpose, I keep the folder and my working things in the desktop. So I connect and go my network folder. Right. I connect all webinar folder here. So now you can see it was already like this. So when you click this arrow button, you can see my connected file, right? This is the file I have connected. So in that way, you also can connect the folder by using the folder connection. So inside this folder, this is my layer. This is my root layer, right? So if I want to do a network analysis and the network data set model, first I have to clean the data. Now this data is dirty. So I have to clean that data dirty. So for that cleaning, what is the function is giving from the ArcGIS Pro software? It's called topology. Some people you may have known already. So freshers, you don't want to worry. So you can get, once I go step by step, how to create topology and the network data set. So through this, first I want to clean the dirties. Dirty means here, when you zoom in this one, when you zoom the layer, you can see some junction. See, this is the junction. These are the junction. So this is the junction. So in this junction, if we want to do a network analysis, now you all can see this light green line, right? That is continuously going from here, somewhere there to here, right? But if we keep that line as it is, it won't work. Why? Actually, we want to find the shortest path. For example, I can say, so this is one location and this is another location. So if I want to find out the shortest path from A, this we call A, this is we call B. So from A to B, if I want to find the shortest path, so without cleaning the data, what will happen? It will find the trace like this way, this way, this way, this way, and this way, and going up to where this light green end. From that, it will search to come this B location. So that is here, it's a problem. When we concern about this, it's a problem. So for that purpose, what we want to do is we have to break it here. If we break it manually, it takes long time. So there are functions. If the breaks in this junction, what will happen? The shortest path from A, it can travel this way and try to turn here and will reach B with the proper shortest path. So for that, we should have a junctions. All right. Before thinking about this breaking the junction, what we have to do is we just want to have, are there any overlaps? Overlaps mean there's a line here. So if another line be top of this line, we call overlap. Likewise, sometime there are lines, it may be like this. If the line has gap, can we do the shortest path, or like can we connect these two in one line? No. So first we want to find whether there are errors like this. First overlap, and this is called the angle. And sometime there are undershoot, we call in a term technology undershoot, and there are overshoots. So we have to check all those errors and clean. After clean the data, then only we can do this network data set model. Right? So for that, what we have to have is we have to have a geodatabase. So without geodatabase, we can't have a topology. Topology means cleaning the data and the network data set, right? So for that purpose, we are going to create a geodatabase, right? So here, I'm going to hello, yeah, sorry. Sorry for the technology inconvenient. So can anybody tell me that now can you see my screen?
Yes, we can see you. Sure. Yeah.
Yeah. So I will repeat it again. So we have to clean the data, right? We have to clean the data. Without cleaning data, we can't go for network data set model. So I repeated that data where we have the errors. So let's say if it is a line going this, and if we have a gap here, we can't do the network analysis. So first we want to find whether are there any gaps. Likewise, there are overlaps. Overlaps mean this is the baseline. There's another line. On top of this line, we call overlap. Likewise, there are undershoots and the overshoot, right? So we have to clean those data by using a topology. So when we create a topology, the topology Yeah. So when I zoom it, I think technically it will get struck. So I will keep this extend zoom and I will explain. So what I have explained is, I just summarize. If there are any gaps in between line, we have to connect that line. And if there are like undershoot and overshoot, we have to connect that one. As well as if there are any like overlaps, we have to remove the overlaps and make it single layer, right? So to do the topology, we have to have a geodatabase. So now I'm going to create a geodatabase. So you can right click on top of your folder where you want to keep that file geodatabase, and thereafter you can create and name it network data topology. Inside this geodatabase, we have to create a feature data set. Inside that geodatabase, we have to create feature data set. So now I'm giving the name called road topology. So here we have to give our coordinate system. So since we are Sri Lanka, now I'm going to give Sri Lanka coordinate called Kandawala Sri Lanka. That is our local coordinate. Now I'm going to run. So now I have created the feature data set. So inside this feature data set, I'm going to bring this Sri Lanka layer inside this feature data set. So for that, I will import that feature class. And run it. So now almost I took this out layer inside this feature data set. Now, on top of this road topology, not this geodatabase, inside the geodatabase, we are having the data feature data set. On top of this feature data set, you can right click and go to new and topology. So when you click a topology, you will see the pop-up screen like this, and you tick here. You can tick here and go to next. In here, you can have click here to add a new role. So on top of that, when you click it, it will ask Sri Lanka. If you have a data like Sri Lanka or any other layers inside, it will show to select. Here only we have Sri Lanka, so it will show only one selection. So now I'm going to select Sri Lanka. And in the rule, I'm going to give several topology errors. So I want to check must not have overlap, right? Must not have overlap. That is my first rule. And I'm going to give another rule. So if I want to give another rule, again, you can click here to add a new rule. So again, same Sri Lanka, I'm going to add another rule called must not have dangle. So these two rules, just to have idea, these two rules, I'm going to run and show it how the errors spreaded over the line. Right now I click next and finish. Now you can see the topology. If you don't see, you just refresh, then our topology, it will come. So now I'm going to track into my project. So now you all can see the topology. So after create this topology, I have to validate by the inspector. So the inspector is in edit, in the edit ribbon, you can see the error inspector here. So when you click error inspector, now you can access to validate where are the errors there. So here there's a validate button. When you validate it, it will pop up where the errors spreaded over this line. Now you all can see, right? So these red areas saying the locations, it has some errors. So we have to connect those errors by doing manual works. So it means it may have dangle or it may have overlap. So we have given two rules. So based on these two rules, it has given the result with the highlighted small square icons. So when we zoom this icon, when we zoom this area, we can have actually what has happened, the idea of what has happened. I will show. Yeah. Yeah, this is actually, I clean the data. I will just import this layer. Then I can show the real error. So I will delete this topology again, and I will redo it again for that error layer only. Now I mistakenly take that corrected one. So I just want to show it where the errors are there. So you can right click here and go to the topology and select roads and go to next and select the road and rule add must not have overlap, and again I will select for the must not have dangles. So next, finish. So now I will refresh. It will come like this. So after I go to the edit and click the array inspector and validate. Now you all can see this line actually not connected. So for that, what I can do is I just can click here and right click it and go to edit vertex. In there, I have to add one vertex here to keep this location here, and I will just drag to here, and now it connected. So after, if I give the validate, it will disappear that square icon because now the line has joined. So now you all got how you can correct the errors, right? I will do another one also. So these are the square. It highlighted as a dangle, but actually this is dead end roads. So this is of course exceptional in our cases. So now I will repeat that same function you to get more idea. Now see this line, it is not joined. So to clean this error, what you have to do is you can click here and right click and edit vertex. And here you can delete this vertex. Now you can see this is overshoot. And when you validate it, now it disappeared because now we have cleared the errors, right? So in this way, you can clear the errors where the errors spreaded over the layer, right? Hope now you all have got idea about the topology, right? So what we are going to do by using the topology, we check the errors and we remove the errors and clean the data. After we clean the data, then only we can create a network data set, right? So now almost we have given 2 rules. So to get the idea, but you can apply more rules if you want, or as your requirement, as your data, you can apply more rules to clear your errors of the topology. So to remove that errors, you are using the topology. So that topology is created by using a geodatabase. So once you create a geodatabase, inside the geodatabase, you have to create dataset, feature dataset, and inside the feature dataset, you have to bring the layer inside the feature dataset. It means you have to import the layer where you have out. So then only you can create a topology. Now, I hope you have understood the topology. So topology is a important a function you have to do before you create the network data set. Now I will remove this topology and I will jump to yes. The thing is, now when I click to remove this layer, it asks whether save or discard. After we remove these errors, we have to have save. We have to have save. So then only what are the works we have done, it will save. Otherwise, if you miss to press the button save, so whatever the works you have done, it will not save. So it will be pressed again. So make sure you have to save the data you have edited. Now I'm going to remove. Now I will go to my folder connection where I want to create the network data set, right? So in the network data set, I'm going to create a file geodatabase again to create a network data set. Now I'm going to give the name called road network. So after I create the geodatabase, a name called road network, I'm going to create the feature data set. So on top of this geodatabase button, you will click, when you right click it, it will pop up new. In the new, you can see feature data set, feature class, likewise. So I will click it, the feature data set. So again, I'm going to create the name road network data set. So I will sort RDND and I'm going to give our local coordinate called Kandawala, Sri Lanka. So this is the shortcut when you enter the number, if you already know, or otherwise you can search and find and click it, then it will come. So now I have created a feature data set. Now I have created a feature data set. Now for the cleaning, I will delete this road because I keep these roads layer to have the idea by you how you have how you can create a topology and how you can clean the data. So before we prepare the network data set, we have to have a data with full clean. So now we clean the data. So there are a lot of errors. So we cleaned by manually doing these topology errors. And this is my clean data called Sri Lanka. So now I will delete this plot because you may have confused if a lot of layers here. So this is the road layer that I have cleaned that errors must not have dangle and must not have overlaps and some other, right? So after that, before I want to bring it inside this feature data set, I already explained I have to break the junctions. I have to break the junction. If I don't have junctions, what will happen? If I don't have junction, what will happen? If I keep a shortest path from this location to this location, in here, if I don't have a junction, what will the system do is it will trace the line from here to here and here to here and search where is the end point. So here there is no end point. It will continue up to here. So after that, if any junction there, then only it will direct the where it should go, the target point. So for that purpose, we should have the junctions. So here we don't have junction, right? You can see here we don't have junction. So if we don't have junction, the system will not know where it has to turn, right? So if the system doesn't know where it has to turn, then what we'll do is it will search up to end of this point. Then only it will turn right side and come this way and this way and this way and this way and reach this location. So that is not the real shortest path analysis. So for that shortest path thing, we have to have a junctions. To do that junctions, there is a function called feature to line. There's a function called feature to line. So inside this catalog pane, if you don't have the geoprocessing tool, what you have to do is go to insert, go to analysis and click the tools. Go to analysis and click the toolbox. So now you can see in the catalog pane, the geoprocessing favorites and toolbox. Here you can search that specific function called feature to line. So now this is the location under data management tool, feature to line. So I will select the Sri Lanka layer and now I'm going to run. Now you all can see the feature to line. So the feature to line, what has happened, it breaks the junctions. Now you can see the junction, but already see the previous layer, it does not have junction here. So now what has happened, it generated the junctions. When you click the layer, single layer, wherever the junction is there, until that point, it has broken. Until that point, it has broken. I will explain, but this is also, we have to do it manually because there are roundabouts. So in that roundabouts and one way, so we have to consider those things and do it manually also to get the proper layer. But for time being, for your idea and understanding, now what I have done was I have broken all the lines where it connect with the another line. So in that purpose, I used feature to line. So now I have this feature to line layer. So in this layer should come under my network data set. it should come to my network data set. So what I'm going to do is I have created geodatabase. Inside the geodatabase, there's a feature data set. Inside the feature data set, I'm going to bring this feature to line data here. So for that, I will right click and go to import and feature class. When you keep the layer in your project, it will show here to select. Otherwise, you have to browse your folder and bring the layer where you save. So for the convenient way, you have to add any layers in your project and bring it inside that feature data set. Now I click it line to feature to line and run it. Now I'm going to refresh where my layer has been imported. So now I will remove from this content pane. Now you can see the feature to line data, it has come, it has imported. So now I have to create the network data set model. The network data set model I have to create on top of the feature data set. So when you right click here, you will have new pop-up, and in there you can see the network data set. So when you click the network data set, there's a pop-up window. It will show like this, and you can give a name for your network targeted layer that has been Sri Lanka feature to line. So now I'm going to give network data set name is SL network data set. I shortlist, I type it here, SLND. So here the source feature classes is here. You have to checkbox. You have a checkbox. You have tick it and run. After you run this network data set, you will have a window automatically in your project. It's covered by the light purple color. Now I'm going to remove because I have to add some properties and attributes. So when I want to add the attributes through this property, if the layer it is in the project, it will not allow to edit or feed any attributes. So for that purpose, now I'm going to remove this pop-up layer from my project. So after I created the network data set, I'm going to set up my properties. So you click it on top of this network data set, which you have created, and right click it and go to the properties. In there are lots of attributes. You can feed it. Right? Sources settings. In the sources settings, you can see sources, vertical connectivity, group connectivity, in traffic, travel attributes, cost, restriction, descriptors, time zone hierarchy, directions. So there are lots of attributes you can see in the properties of your network dataset. Now I'm going to create only the one attribute that we should have basically, then only the function will run. So just to have an idea how it's run. Thereafter, if time permits, I just can feed the attribute called cost or restriction or descriptor. So now I will skip this one and I'm going to give only travel mode and new and okay. I just keep it default, only length and okay. To run this one and show some network analysis to all. After that, I will just give some ideas how you can feed your attributes. Before that one, now you can have an idea about this one, then only you can have understanding about why we want to give the attributes called restriction or descriptors or like cost. So now I'm going to, after I have set up this attribute setups, I have to build these network data by using build. So when I right click on top of this Sri Lanka network data set, it will pop up the build. So when I run this, it will build. It will build. So now you all have an idea how you can create a network data set. I will repeat it up to this point. So what I have done, I have the road layer. So I added that road layer into my this project, and from that layer, I want to have an idea whether that layer has errors, whether that layer has any errors. To check those errors, I have created a geodatabase. Inside the geodatabase, I created the feature dataset. Inside this feature dataset, I imported my target layer. So that is roads, name called roads. So this layer I imported into this feature dataset. Now you can see the difference. This one shapefile and this is feature class, but in somehow it gives same properties, but there are advanced things this feature class has. Why? Because we keep this shapefile as a feature class. When we convert this one, there are lots of advantages and advance it has. So in that purpose, we brought the shapefile as a feature class. So there's a question, can we do the topology for this feature class, also shapefile? No, only if we keep this shapefile, when it comes inside this feature dataset, then only we can access to do the topology and check the errors. So in that purpose, we imported inside this feature dataset. So after imported that specific layer inside this road topology feature dataset, I can enable the topology. So what I have done, I created topology. And after I create the topology, I went to edit ribbon, and there's a array inspector. Through the array inspector, I have found there are errors. So after I found that errors, I try to clean it by manually. And after edit those errors, I press the save button to save what are the works I have done. So hope you know how to create a topology. So to create a topology, what are the requirements? We should have a geodatabase. Inside the geodatabase, we should create a feature data set. Inside the feature data set, our target layer should be imported. After imported the layer, we have to create a topology. So topology, it has lot of rules. So we have to add that rules to achieve, or ultimately what are the errors we have to remove. So based on our expectation and requirements, we have to add the rules and check the errors. In there, we can find the errors and remove the errors and save as a clean data. So now what I have done, I imported that clean data into the next data set, feature data set. Even you can create inside this RD topology also this network data set. But for your clear understanding, I keep separate as another geodatabase and created feature data set. And I brought the clean data, but that is actually the clean data. It doesn't have the junction breaks. So that was another problem. So what I have done to correct that junction breaks, I have done the feature to line. So after the function called feature to line, that specific layer, I imported into this separated feature data set. And on top of this feature data set, I created network data set, right? Inside the network data set, I went to the property and set one default settings. And after that, on top of this network data set, click on top of this network data set and press this build button. So now almost the data is ready to have our requirements. Where are the shortest path? Where are the closest facilities? Where are the service areas? So those analysis we can do now. The data is ready. So now I'm going to bring the Sri Lankan network data set into my project. Now you all can see inside the project, there is a network data set. There's a network data set. Now I can access what are the requirements, means shortest path, closest facilities, and service areas, and and others. So now to do the analysis, I'm going to press this analysis ribbon. I'm going to press this analysis ribbon. Inside this ribbon, you can see the network analysis. You can see the network analysis button. When you click that network analysis button, you can see service area, road, or closest facility, so on so. So now I'm going to click the find the shortest path between stops. So when I click there, there's a window. There's the functions, the cluster of function tool. It comes to under contents. So to do that one, I will remove and repeat it again. I came to, after I add my network data set, I came to this analysis ribbon. Inside this analysis ribbon, there's a button called network analysis. When I click this network analysis, it will come this pop-up window. In there, I click find the shortest path between stops. It means route. So when I click, it will come in my content pane. So there's a cluster of function tools. It came to content pane. So now I'm ready to find my shortest path. Now I'm ready to find my shortest path. Yes, now I'm going to give 2 stops to find the shortest path. So to give that one, when I click on top of please give about 20 seconds because I just want to correct some technical issues. Be patient for 20 seconds. Right. Hope you can see my screen now, right?
Yeah, yeah,
Yeah,
Mrs.
right. Thank you. So when after I created this cluster of tools, what I want to do is I just want to keep my cursor on top of my targeted or specific layer. I can just show it to you. So when I keep my cursor on top of SLND, now you can see in the top bar, you can see some difference, right? When I keep the cursor here on top of root, you can see some changes. See, so this is the advantage we can have in this ArcGIS Pro. It's a mobile. It's not static. All right. So when I click on top of this root, there's a pop-up window called root layer, right? Root layer, right? When I click the cursor here, there's a top-up window. It will appear root layer, linear referencing, data, and so on. So now I click root layer, and after that, now I'm going to give the 2 stops to find out the shortest path. So to get that one, you can see once after you click root layer, you can see run, import, stops, and there are 2 small icon buttons. So now I click this create feature icon. So when I click this create feature icon, there's a window. It will pop up like this. Now I click the stops. Now I click the stops and keep 2 points somewhere I want to get the shortest path. So now almost I have created 2 location points, and now I'm going to run here. There's a button run. So when I run, yes, I can have a shortest path here. When I run, I can have a shortest path here. When I click this shortest path layer, when I click this shortest path layer, there's a pop-up attribute window. It will come like this. It will come like this. So in here, you can have idea about the total length. The total length is 119 kilometer. So here it shows in a meter. So that the total length actually it will calculate. Okay, now you just have an idea how that shortest path it comes and give the attribute. So if you want to separate this layer, you can click, you can have the roots. See the roots. When you right click here, you can export this separate layer in your specific location. Now I have created the shortest path and exported my shortest path layer as a separate. Now I'm going to tell you what if you want to calculate the time. If you want to calculate the time, you can have, if you want to calculate the time, you can add an attribute and calculate the time. I will just show how you can add that time. So now I'm going to add time attribute. Now I'm going to add time attribute, and this is a calculation. So I keep as a double. I keep as a double attribute and press the save button. Now I have created the attribute called time. So now I'm going to right click on top of this time and go to the calculate field, and in there I have the shape length. I have the shape length. Yeah, total length divided by 1000, because I have to convert it into kilometer. 1000, and I will keep it bracket. And I'm going to give speed for time being. I'm going to give 70 per kilometer for this speed. So now the length divided by speed is time, right? So now I'm going to add the time here. So when I apply an OK, this is my, yeah. Yeah. Now I'm going to give 50 kilometer per hour, because this one has C class road, B class road, A-class road because I did not have any category. So now almost I want 2 hours to reach this location, right? Now you all can understand. So the time also we can get when we click it here, when I click this on top of this layer, we can have a time attribute also like this total length. So we can have total time. So in that thing, what we have to do is, I told you, go to the attribute and I have to feed it the cost. In the cost, now I keep my layer in this content band. So I don't have, that is why it will not enable. So if I keep this layer inside this the feature data set, it can be enabled. So likewise, you can add what you have, what you want to do, what you want, what is your expectation. It means if you want to get the results called time attribute, you have to feed the time attribute in the cost, in the cost property, in the cost property, in the cost property, you can add your time, right? And likewise, if you have a one-way restriction, or if you have a vehicle, your vehicle height restriction, or any other restriction, the payment, the road payment restriction, or like any other, sometime let's say you may have the construction work. So or sometime you can't use that road. So you can specifically give that attribute and you can tell the system you don't want to go that way and you have to give the alternative way instead of that way. So those are the functions you can feed it, you can insert it, right? Now I'm speedily going to the next analysis called closest facility or service area. Now I'm going to remove this one. And go to analysis and the closest facility. Go to analysis and the closest facility. So now you have the closest facility. So in this closest facility, you have facilities and incidents. So when I keep cursor here, it will enable to pop up like this. And I press this button icon. And now I'm going to click the facilities and put the facilities somewhere here. Like this. And now I'm going to click the incidents. So you can try. So now I'm going to run. So now you all can see, from this location, there are shortest path. So this is the incident location, this is the facility. So from this incident, you can get the facility here, right? From this incident, you can get the facilities here. So these are the shortest path for this facility. From these 3 incidents, you can find this location as your facility. So from this facility, you can have this incident, right? So likewise, it is a cluster. Now you can see this is not defined. This is not defined. This is not defined by its the default tolerance. The default tolerance is 5,000 meters. So this location should be closer to less than 5,000 meters. Then only it will draw a line for that incidence or facility. See now, when you check this length, it may be more than 5,000. So it because of that, these are not included under this category. These are not included under this category. If I change this tolerance, I just keep kilometer, 5,000 kilometer. when I keep this one and run, now you all can see, now it put this one. So here there may be some geometry error. So geometry error, like as I said, some that data cleaning part, it's because of that we don't have like the proper data layer. So it's because of that this one keep as a separate. I think now you all have understood how it works, right? Yeah, okay. Now, yeah, not only that purpose, not only that geometry error, when you check from this length to this length, when you check from this length to this length, it may be more than this length. It's because of that this facility, no any incident, it not required to get this facility. Okay. Now I'm going to do this service area analysis. Now I'm going to do the service area analysis. So before you have to remove, you have to discard or save. I'm going to discard now. I'm going to delete this one, and I'm going for the next analysis called service area. So I just speedily press facilities. So I'm going to give the facilities here. So in here, I will ask 10 kilometer. It means 10,000, 20,000, 20 kilometer, 50,000. In between this length, I'm going to ask to generate the service area. Now you can see this is the service area. Right. So from this location, if you go 10 kilometer, if you ask the system to wherever 10 kilometer, here you can see if you find any location, it should be less than 10 kilometer. If you find any places somewhere here, from this point, you have to come like go here, go here, go here, go here, and go here, again come to here. So the length will be increased. You have to have a clear idea in here why this shape from this location. If you go here, this length less than 10 kilometer. But if you come here, in this point, if you come here, it is more than 10 kilometer. It means less than 20 kilometer. Why? In the route, it doesn't have the roots. If the roots somewhere here, it will show this one also less than 10 kilometer, but it does not have roots. So if you want to come this point from this location, what is the route access? I have to go like this, and this, and come to here. So then the length will increase. So service area, you have to have an idea why we are using this service area. So hope you all have understood the network, how to create the network data set, and how you can apply based on your requirement. What is the requirements, like let's say shortest path or closest facility, or like cosmetics line. So all the things you can try and do it as yourself, right? So now I will stop this network analysis, and I'm going to move the raster calculation analysis. So over to you, Chamodini.
Okay. We believe that you have gained an excellent understanding of network analysis. So now Mr. Sivaravan will share his insights on raster analysis. Mr. Sivaruban.
Yeah, thank you, Samodini. Now I'm going to move to the raster calculation analysis. So it's a kind of raster calculation, but you just have an idea through these raster things, which is the mechanism it's behind to get the output. So that basic, to give that basic, I'm going to do one of suitability analysis. So through that one, how these raster things, it's the mechanism, how it works. So you just try to get that idea. So we will do a lot of raster analysis in our future programs. So to have basic and simple idea, I'm going to do a suitability analysis by using these raster things. So there you can get the understanding how the mechanism it's work, the raster mechanism it's work. So now I'm going to discuss, I just want to find the location to put my business. To select a business location, I'm going to do this analysis, right? So if I want to think about the business, there are competitors and the points of interest. Points of interest mean the supporting things for our business. So we just to have that idea about our competitors and the point of interest. It means our supportive interest, our supportive investors. So for that, I selected sample competitor location. It's closer to our office. So I just want to give some basic ideas. I got competitors location, population, roads, and the existing business location also, right? So for time being, I just remove that existing location business. So now you can have an idea where this location. It's loading my base map. So it's in a Colombo district, Colombo, one part of area. So this is the point of interest, competitors, roads, and population layer. I have 4 layers called interest of points, that is supportive points, the competitors, these are competitors, and these are the roads, and these are the population. So I'm going to do that suitability analysis. So while I'm doing that one, you can have an idea how this mechanism it's going to make the raster, and from the raster how the output comes. So that is the idea. From this you have to get it. So now to the competitor, to the interest point and the road, I'm going to give the distance called 500-meter distance. I'm going to give for each. So to this one, you can go to the geoprocessing bar and search it distance. In there, you can find the Euclidean distance. There are other distance you can, as your requirement, you can apply that one. So now I'm going to select Euclidean distance, and I keep my interest of that supportive points And I will ask the system to keep the cell size called 50 output cells, and the environment I will keep as it is for time being. So if you want, you can give that the required parameters. So now I'm going to select the current display extent to this interest of points. And now I want to give the distance, how much it should be. So I'm going to ask 500 meter and I'm going to run. Now you can see from this my competitor location. From this competitor location, it generated the file. From the competitor location, it generated it. $500 right? 500 meter. So likewise, I'm going to give the competitor. Now I'm going to give the competitor. So my name, I'm going to give it competitor. Yeah, competitor. I keep the default one, and the settings, the extent I'm going to give, I keep that project, and I'm going to enable that competitor location. And after that, I'm going to give the current display extent and run. Yes, now I created the competitor distance. Now I'm going to create. So now I'm going to delete this one. I'm going to remove this one because I have created the distance. Now I'm going to select the road. The roads. From the road location, I'm going to give 500 meter, and in the environment, I want to specify the extent. So I keep current display extent and run. So now you all can see from my from the road location, I have created 500 meter distance. You can see it's 500 meter distance. So after that, I'm going to create the population map. After that, I am going to create the population map. Population, this is my population. So I'm going to symbolize this population and show how the population is spread. So I'm going to create this one into 3 natural breaks and keep it like 6,000 is one, and 12,000 is the another one, and over there. Now you can see this is the population map of our part of Colombo. Right now I want to make this as a vector file. This is as a vector file. This is as a vector file. So now I want to change into a raster file. So vector to raster. So India, I'm going to search to raster. To raster or vector to raster, as you wish, you search it. Or polygon to raster. Yeah, polygon to raster. That is in the raster to raster, and then it is under main conversion tools. You can see polygon to raster. When you click it, you can have a selection population. And now I'm going to give the population called total population. I'm going to give the attribute called total population. I'm going to give the attribute called total population. Here TP, right? Total population. I'm going to give the total population now. So I have to change the valid field called TP. TP means total population, right? Now I keep the cell size as 52. Or I can reduce this one. So if I reduce, the system takes time. So I keep the default cell size and keep all other parameters as it is. And now I'm going to run. Yes, now I remove this vector file. Now I'm going to remove this vector file. Now you all can see this is the population file. This is the road one. And this is the competitor. And this is the interest of points. Interest of points, I want to find a location to build up a business. So to that one, I have a competitor, I have supporters, I have a road layer because road also so concerned one, and the population, right? So now I have come to like a raster, but that is not real pixel based mechanism. So I have to make it in a pixel based mechanism. Then only actually the raster calculation and the raster mechanism, it's being done by pixel based functions. Pixel, based on the pixel, it calculates the statistics, and after that only we can get our ultimate ultimate result, right? So for that purpose, what we have to do is we should have the raster layer. It should have the pixel information. So from the pixel information, the raster is functioning and giving the result to us to perform our day-to-day target, day-to-day needs. So now I want to reclassify. When I reclassify only, it will come as a pixel-based mechanism. So now I'm going to reclassify. What I have done up to now, I'm going to reclassify. So there are reclassify 3D analysis and the spatial analysis. It's from the spatial analysis. So when I click this one, now I'm going to add the interest of points. And here you can have the interest of points. Here you can have the classify option button. When you click this classify option button, you can have natural breaks default 5. So I'm going to keep it as 3. Now you can see. So I want to change this one into 150 meter and 300 and over than 300 up to 500. And now I'm going to OK. So now based on this one, it will generate the reclassification. Now you can see the reclassification. See, this is the reclassification. So from the location, I will add and show this is the interest of points. Interest of point. From the interest point, 150, 100 and 300 and 500. So now this is the, I will rename it interest. So now I will remove the interest. or I will untick until I finish this reclassification. Now equilibrium, the distance for the competitor. So now I want to change it, the reclassification for this competitor. So now I'm going to select the competitor, and I have to keep same classification. $150. So defaultly it will give natural breaks. So when we change these parameters, it will change as a manual interval. Or like straight away you can go the manual interval. $150, 300, and apply. Okay. So I'm going to give the name competitor. Yeah. Because if I keep a lengthy name, then it will not run. Now I'm going to select the road. I will change the name called road. I hope you all know how to handle this ArcGIS Pro. So that is why I will not get time to go deeply and down to explain to you. I hope you will have basic understanding about ArcGIS Pro. Now I have created the road, and now I want to divide the population. So population distance layer, so not distance, that we have changed polygon to raster. So now I will change 6,000 and 12,000 and over than 12,000. So now I'm going to give OK, and I'm going to rename it population. So these four are our targeted layers. Now we have come to our pixel based analysis. Now we have come to our pixel based, it means a raster basis analysis. Now you can see this is a population. So in this population, the number 3 is high populated area, number 2 is second one, and number 1 is third. So in here road, this dark purple is from the location, competitor interest. So now you all can see from this road layer, This purple one is, dark purple one is 150, 300 and 500. So likewise, all those three layers I have divided into three groups. That is, first one 150, 300 and 500. Okay. So now I want to bring all these four into one mechanism to get the real output. The real output means where my location, where is my location is suitable. Where the suitable location is waiting for me. So just I want to find out that one. So now I will skip this one. And come to. Now I'm going to find where is exactly the suitable area. So in that, there's a function called weighted overlay. Weighted overlay. So I just type it overlay. You can see under spatial analysis, weighted overlay. So in here, I have to bring these four. The thing is, as I converted from points to raster and polygons to raster, so in the pixel based. So I have to bring these four in this weighted overlay function. So here I'm going to add population, roads, competitor, and interest of point. Now I'm going to add. Here you have to have the idea. Now the population. When you check the population, the dark purple is the third one. Why? This is less population. This green one is the second highest population. And this color is the highly populated area. So here, the number 3, I have to bring this number 3 in this value as a first. Why? Because this orange color is the highly populated area. So I have to give highly populated area as a first value here. Here you can see, if I select this population, when I missed one layer, competitor and interest of points. Yeah, now all 4 layers here. So when I click population, it will pop up value and scale. Under here, you can see the scale ranges. So I keep this range as 1 to 3. I keep this range as 1 to 3. If you want, you can give more. And the maximum influences mean percentage. It should be less than, it should be correctly 100. It should be 100. So I have to keep that 100 for all these 4. I have to keep this 100, all these 4, and I have to divide it based on my target or requirement. So now I keep population influence 50, population influence 15, right? Population influence, and now I'm going to give it 15. So in here, the highly populated area, it says number 3. So that is the one I should keep in my value as a first. So I have to change it 3 to my first value should be high populated area. So high populated area number 3. Then second, I will keep second, and third one first. The first one is that the dark purple color is low population area. All right. Now the roads. To the roads, I'm going to give 25%. So when you click this road, now I go to this road, you can see from the road layer, this purple is closer. It's closer. So it's very important factor to me to build my business location if closer to me. So 150 meter is so close. So I will keep the first one as a first value for me. So second one as a second value, and third one as a third value. And likewise, I'm going to give competitor 10%, and I'm going to change that is also same like 1, 2, and 3. Have an idea why I'm keeping these values? It's because of the closeness. So now I keep these interest of points. So here I'm going to give 50% because the interest of points is so important factor to me, because the supporting location, let's say for visa cut, if I take for example visa cut, what are the supporting location? Parks, and other like KFCs, not KFC, like let's say parking, tourism area, and these hotels. So these are the interesting locations, the interest location. So competitor location, yes, as I said, the KFC is a competitor for to build a business like Pizza Hut. So for the Pizza Hut business purpose, business behind this, that one, KFC is competitor for the Pizza Hut. So in that way, we have to get this analysis. And road, yes, let's say for road, from the road, we in between 150, if the location is there, then that is easy to get the customers. So in that purpose, we divided into like these influencers, and for the influencers, we gave the values according to our business analysis. All right. Now I'm going to give the run. Before that one, you should have idea why we gave these influencers in different percentage, because the interest of points I have to give more, and the competitor, that is also influenced, but that is, it's not even even it's from my point of view, it's less is okay. So likewise, you can have an expert knowledge of these business people and get the idea, and after that you can put these influences and the values. Now I'm going to run. So my final output, the first priority area is red, and the second priority area is green. So if I enable my base map, okay. So if I keep the population map, then you can have idea where that the suitable location it came. It's a little bit loading. Now you can have idea. Yeah, this is my interest of points. Right, these are competitors. My business competitors, and this is the road. and this is the population. So now you can see the highly populated area, and the interest of points, and the interest of points as a black, and competitors I will show as I will keep it in a different color, then you can see clearly, right? So you can see highly populated area and closer to the road and point of interest, my supporting location. For me it means for my business, what are the supporting locations? So the black locations are my supporting location, right? So when this is my final output. So when I keep this final output, exactly you can see, for example, you can take as a pizza cut. So pizza cut have a competitors. Competitors mean the foods which are making as a pizza as a pizza cut interesting, as like let's say KFC, or the food like pizza cut, some other like Domino's. So those are the business people who are competitors to the pizza cut. So now the competitors, you can see the blue are the competitors. Blue are the competitors, but you can see the supporters also so close. See, so the red, the value, weighted population value, this one. See, the dark red area is the most suitable, and the green one is the second suitable area when we categorize. After that, what you can do is, if you want to send this one, you just polish this raster by converting polygon, smooth polygon, or if you want to do the smooth polygon, you have to convert it raster to polygon, and after you convert the polygon, you can do the smooth polygon. Now I just speedily show it because we are running out of time. Right now I'm going to smooth this polygon. Now I'm going to smooth this polygon. Smooth polygon. Yes, smooth polygon mean it will adjust these territory areas and it will give, but that is not exactly, I'm not suggest this one because it will make the results in a less amount when we consider, it will like change the territory. Smooth polygon, smooth. There are boundary clean majority filter, you can use it. Now I just yeah, smooth polygon. You can apply any tolerance which you want. And just give 100 meter like that. Yes. Yeah, now you can see the territory is changing. So after you prepare this one, you can just symbol it according to your interest. So I'm going to give this graduate, but here the attribute called grid code. Grid code is the one that has come as our expected results. So hope you all got idea about this raster analysis. So raster is when you click this one, you can have the pixel. You can have the pixel. So like let's say if we take the photo of you, there are pixel. That pixel is very small, very small. Even we can't sense by our eye. So each pixel has the values and that colors, right? So from the colors only we could see we are I'm a black, you are white, fair. So those colors, it's because of the pixel size. When the milli calculation that pixel size, that can give more resolution, right? More resolution. Let's say for pixel size, when it get reduced, it gives more resolution. When pixel size, let's say 300 meter pixel, so it can have large information. It cannot have the large information features. It means, let's say 1 centimeter pixel is there and 10 centimeter pixel is there. So 1 centimeter pixel, it has lot of pixel and give so many difference. So from the difference, we could see our colors. So if the pixel size increase, let's say 30 meter pixel size, we can't see the color difference. So likewise, the mechanism is raster behind this is the pixel. So try to understand that pixel. So now we have done this weighted overlay. So in that weighted overlay, what has happened? It get that pixel value of each layers and get the average. So thereafter, it summarize our weighted overlay. So hope you have got to understand about this raster analysis and the network analysis. So with that, I'm going to thank our team, Mr. Sugun, who is the manager of our organization, and Mr. Logit, and our admin people. With that, Isuru, Samanmali, Chamodini, Dilhara. So those are the team. They supported us to bring this webinar today. Overall, I hope we have done well to give idea to all. Overall, thank you all. Over to you, Samodini.
Okay, thank you, Mr. Sivarupan. Now we are transitioning to the Q&A session. If you have any questions, please raise your hand because we are running out of time. We can give 5 minutes for the Q&A session. During the Q&A session, you can download the quiz that we have provided through the chat box. You can complete and submit using this link. So if you have any questions, please put your questions into the chat box.
Yeah, there is a question from Naimhat Mullah. Do we generally get these type of topological errors? Is every saved from open source? Yeah, yeah. You asked that whether that topological errors from open source layers. Yes, may be and may not be. It's depend on the layers which they are providing. So before they provide, if they check those topological error is normally we can't have the idea because it's the topological error. It can if we go like manually find these topological errors, that is not actually we can't get these errors when we check manually. So this is the specific topological error checking mechanism. So you have to apply that one. Even though if you feel that whether that topological error, that specific data doesn't have, so you should add these rules and check. If it is there, you have to correct it, or otherwise you can yeah, you can do this topology function to rid of these errors.
And Shiva, I will also add something for your answer that shapefiles, any shapefile may contain topological errors. So when we want to do special work like network dataset or any parcel fabric or special datasets, we have to run the topology and check the errors. So that will clean the dataset. So before having the network datasets, this type of road network or utility related networks, we need to do that error checking, even it is open source data layer or another any other secondary data source. We have to check and find out the errors and fix them. Otherwise, we can't run these models.
There's a question from Ananda Kumarasri. Yeah. Are there any tool that can detect or correct topological error rather than manually doing it? Yes, Ananda Kumarasri. Yes. The thing is, you can correct the errors by doing some exceptional correction, but even though if you correct that one, when you run this network data set, it will not run. So that's the case. You have to go through these things as after you find the errors, you have to correct it manually. Hope Mr. Subban, I gave the answer correctly.
Yeah, that's yeah, we have to check manually, and we have trim and extend capabilities where you can extend and trim kind of capabilities are there. And also something called cluster tolerance. We can change and see, but some cases we have to manually intermine certain exceptions and identify the real scenario there. So as Shiva mentioned, some cases there are dangles, but errors, but they are not actual errors. So we have to identify them as exceptions. So that is we need to do in a manual way some cases, but there are places we can do it in a kind of automated mechanisms. Yeah.
Yeah, Nishanti, yes, you asked that. Yeah, it can be shareable, so you can get the contact with our team, and you can get this as a video record. I hope.
And there's another question: can we do this analysis using ArcMap? Yes, definitely. You can build network datasets using ArcMap. Different versions, that capability was there. But in Pro, you have more convenient tools, and there are ribbons for that. So in ArcMap, you will have the toolbars. Yes.
Yeah, Viskas Rivardhan, yes. Yeah, you can download nowadays this open source layer is there. So there are errors, but you can correct that errors and you can check it.
And there's another question: do you give any trial version? Yeah. Yes, you can get trial versions. Please contact us, and And also we are having maybe end of this month, we are having more professional training on network analysis, maybe long one with various exercises. So that will be available in the future. But if you require trial versions for practicing this, please let us know. We can support you on those cases. Yeah.
Yeah, Mr.
Yeah.
Subban, there's a question. How can we join our team? So can you respond that question?
Yeah, actually, currently we are having a team of technical and the other pre-sales and different combination of people. So if you are interested in certain things, you can send a CV, and if you are perspective of joining the team, so that's a one method. But I mentioned at the beginning, if you are interested in joining webinars, let us know maybe what are the areas you are specialized in, kind of things. Then we can have kind of a chat first and see whether we can do kind of a combined webinar with users. So there's an idea like that, to have a webinar with users. So then we can figure out on that perspective. But for joining team, please discuss with us. We have some open opportunities in these days also. Right.
Okay. Now we can close the Q&A session, Mr. Suppu. We can close the Q&A session now.
Before that one, Samodini,
There's another question, right?
yeah, Mila
Yeah.
Yeah.
Mr. Subban, can you respond that?
Yeah, since all layers you used are vector data, can we do this as a vector data analysis? So network analysis is a kind of vector data related analysis, totally depending on the linear data sets. So that we can take as that way, but anything related to the raster, it should go to the raster analysis. But there are combination of both analysis in some cases. Yeah. I hope she's referring to the network analysis.
Yes,
Please,
Mr. Subban, yeah.
Yeah.
She asked the second one, yes.
Yes, yes.
Yeah, it's possible to get that suitability analysis without the raster, but we have to, it's easy to get the output when we doing as a raster, but say vector also it's possible, but some more functions we have to do it. But we suggest that raster based analysis is best one.
Yeah, because vector data analysis, you can do various geoprocessing tools, combining them, and you can do similar analysis. But the beauty of raster data analysis is you can manipulate the rasters and give the weights, and there are so many. When you take it, you can do a lot of computation quickly. So there are some advantages. Yeah, please contact us for those team joining details. Yes. Mm. Okay, Chamudini, I think we can close the Q&A now.
Yeah, Mr. Super. Okay, now it's time to wind up our online webinar session, and I thank all the participants for your active participation and contribution. So please complete and submit the quiz. We have provided the chat box. So make sure to submit the quiz before leaving the webinar. And also we have displayed the QR code. So you can scan the QR code to download the link. And also you can use the link to submit the form. So I would like to thank GIS analyst Mr. Sivaruban for his insightful and comprehensive presentation on network and raster analysis using ArcGIS Pro. And also I had like to thank our general manager, Mr. Supun Sirivardhana, for organizing and supporting for this webinar. And also I'd like to express my gratitude to Mr. Isuru Sirisimana, the technical support engineer, for his support is making this webinar for more success. So again, I would like to kindly request that to complete and submit the provided quiz prior to leaving the Zoom meeting, because it is necessary to receive your e-certificate. So we will send it via emails. So thank you for your time and attention, and we hope you enjoy this session. And as mentioned, Mr. Supun, we are going to conduct an online course the second week of May about network and raster analysis. So if you are willing to participate, please make sure to contact us. So we look forward to seeing all you again in our upcoming webinars. Thank you all.